Question number 1. In my previous video, I treated how power can be calculated, and I took time to explain what power is all about. I equally stated the mathematical relationship between power, current, and the potential difference. So in this video, I am going to take time to solve or explain question number 1 that has to do with energy transferred in a given second by a current of 2 amps. All right, when such electric circuit is subjected or supplied with 230 volts. So let's see. The question is very simple one. All right, the question is, how much energy is transferred each second by a current of 2 amps, A, driven by a potential difference of 230 volts? How much energy? Look at this. How much energy? It's talking about time rate of energy. That is power. All right, that is power. Okay, so it's transferred each second by a current of 2 amps driven by a potential difference of 230 volts. So we are going to calculate the amount of power transferred or energy transferred in this circuit within very small amount of time when current of 2 amps is supplied by a potential difference of 230 volts. So the first thing we do is to write down our solution. Very simple. Then write down also the data. Data means the information that the question contains. So the question contains current I equals to 2 amps, voltage equals to 230 volts. Then P stands for power, is unknown. So this is the one we are going to calculate for, right? The formula to do this is power is equal to the product of current and voltage. Very simple. The product of current and voltage. So power is equal to, for current is 2 amps, for voltage is 230. So by the time we multiply 2 times 230, we have 460 watts, and that is the answer. Okay, that is the answer. Very simple, right? Very, very simple. Okay, that is it. Once again, if you have watched up to this moment, if you have found value in this, consider subscribing, consider giving me some thumbs up, consider joining me and promoting this learning content, right? Consider putting on the bell button for constant notification each time videos like these are uploaded. Share with your friends, share with your networks, share with your students, families that might want this for their children. Very, very important. Okay, let's do it this way. Drop the topic that you want me to treat next time in the comment box. I will do just like that. Thank you. Now let's consider the second one, the second question. Okay, the second question has to do with power again. All right, what power is dissipated? What power? Look at it. What power is? We're going to calculate for power and look at what happens. Dissipated. That is used up, right, in that circuit by a current of 3 amp through a resistor offering resistance of 10 ohms. Through a resistor offering resistance of 10 ohms. So they want us to calculate that. All right, we are going to apply the second relation for calculating the amount of power dissipated in an electric circuit. And that's, once again, we write in our solution, bring out the data contained in the question asked, and then find power, because power is unknown. So the formula we are going to use this time is power is equals to current squared times R. R stands for resistance offered in the circuit, right? So for current flowing in the circuit is 3 amps, and we are going to square it. So 3 squared times the value of resistance offered in the circuit is 10 ohms, so we substitute with 10, right? And by the time we simplify, 3 squared is going to give 9, and then 10 times 9 will give 90 watts. So this is the answer. Very simple. This is the answer. We don't need to do more than this. It's very simple as that. Very simple, okay? So you can see it's very simple. Just apply it, substitute wisely, and you have it. Okay? That is it. Once again, I urge you to subscribe. Subscribe. Come on, subscribe if you have found value in this. Learning pleasure, learning continues, right? Subscribe, share with your friends, your students. Just give us some thumbs up, and then put on the bell button for constant notification each time something like this is uploaded. Let's move on to the next slide without wasting time. We have the next one, which is a kind of summary. It's a sort of summary of what efficiency or efficient transmission of power is all about, right? Efficient transmission of power. Energy can be transferred by an electric current. What does it mean? Each time current flows, some amount of energy is transferred. Take note. Very simple. I take it again. Each time current flows, some amount of energy is transferred. An electrical appliance needs to be given enough energy every second. So take note of that. An electrical appliance needs to be given enough energy every second, right? Very, very important. Look at this. I'm underlining it now. Yes. Okay? Enough energy every second. Electrical power can be delivered as a low current with a high voltage, or a high current with a low voltage. Take note. And for us to take care of that, we revisit what we said about power before, when certain amount of resistance is offered in that circuit. And that is what we have here as power equals to current squared times R, R being the resistance offered in the circuit. So the equation shows that a high current will have a much higher effect on the transmission wires than a low current. That's what it means. For this reason, transmitting energy at low voltage will definitely affect, okay, at low voltage. For this reason, transmitting energy at high voltage with low current will keep the wires cooler and waste less energy, right? That's what we want to see here. So when energy is transmitted at very high voltage with a low current, the wires, there won't be much wastage of energy. That's what it means. So we must watch out for this. Very, very important. All right, we have come to the end of our learning today. See you in my next video, right? I'll be linking it somewhere here or somewhere there, right? Subsequently, we are going to treat other aspects, other topics that we need to learn in physics. Learning is a continuous process. Don't forget to subscribe. Give us some thumbs up. Come on. Share with your friends and networks, and then remember to give us some thumbs up and put on the bell button for constant notification.